Graphing rational function part 2. Please take good notes. So I'm going to graph this function. The first thing I need you to do with this function is go ahead and factor the bottom. And when you factor the bottom, you will find that the product of -2, the sum of -1, it's x minus 2x plus 1. The reason we want to factor it to see if any factor will reduce, but as you can tell here, nothing is going to reduce. There will be no hole in the graph. As for the vertical asymptote here, when you set the denominator equal to 0, you're finding out that you have two vertical asymptotes. One of them is at 2 and one of them is at -1. The horizontal asymptote is going to be looking at the exponents of x. Since the exponent of x on the bottom is bigger than the top, it's going to be y equal to 0. It's bobo. Bigger on the bottom, it is 0. As for the x-intercept, we're going to set the numerator equal to 0, and in this case will be x equal to 0. Next, we're going to look for the y-intercept, and the y-intercept is going to be making x equal to 0 and solving for y. And so y will equal 0 on the top, whatever is on the bottom doesn't matter, it's going to be 0. So this graph is going to cross at 0, 0. Okay, let's go ahead and graph it. To graph this function, this is the first time we graph a rational function with two vertical asymptotes. One of them is going to be at 2. This is 1, this is 2. The other one is at -1. And so we have two vertical asymptotes. And we have a horizontal asymptote at 0. Good. So now here what we have to look for. If I go draw back over here, we have x-intercept at 0 and a y-intercept at 0. So that means when we look at the graph, we have to break it down into three parts. We have the part that is bigger, this is asymptote, the part that is smaller, and the part that's in between. Let's start with the first part right here. So we have a region 1, region 2, and region 3. Let's start with region 1. If you were to pick any number bigger than 2 and plug it back into the ratio x over x minus 2x plus 1, pick a number, any number you wish. Let's say we pick 10. So 10 is positive. 10 minus 2 is 8, which is positive. 10 plus 1 is 11, which is positive. So positive divided by positive over positive. So the whole ratio here will be positive, which tells us that the graph is going to be above the x-axis. So that means we're going to start near the asymptote, make the graph and near the asymptote above the x-axis. If the ratio was to be negative, we would have gone below the x-axis. Let's go to section 3, or region 3 if you will. I need you to pick a number smaller than 1, because we're going to graph in that region here. So let's say we pick -10. So if you plug in -10 into the function x over x minus 2, x plus 1. If you put -10 on the top, it's negative. -10 minus 2 is -12, which is negative. -10 plus 1 is -9. So those two negative on the bottom, when you multiply them, they turn into positive. Negative divided by positive, the whole ratio is going to be a negative, which tells you you want to go below the x-axis from asymptote to asymptote and finish up your graph. Now the only thing we're concerned about is the middle part. This is the time when I talk about exception to the rule. We're going to cross the x-axis at 0, 0. So therefore I want you to pick a number bigger than 0, between 0 and 2. Let's say we pick 1. So plug it back into the function. 1 is positive, 1 minus 2 is negative, 1 plus 1 is positive. And so positive divided by negative times a positive is negative. So on this side of the graph is going to go below the x-axis. Because when I plugged in a positive one, I get a ratio that's negative. If you plug in a number between -1 and 0, you're going to pick like -1/2. If you plug in -1/2 on the top, it's negative. Negative 1/2 minus 2 is negative. Negative 1/2 plus 1 is positive. But if you look at the whole entire ratio is positive. So between 0 and negative 1, the graph is going to go above the x-axis. So as long as it starts near the asymptote and near the asymptote, this is your entire graph. The last thing we want to do here is the domain and the range. So I'm going to move my graph up a little bit over here and then go ahead and write the domain and the range. The domain, we're going to exclude two vertical asymptote, which is -1 and +2. We're going to count all this region here. We're going to count all the region in between, and we're going to count the region over here. So this is going to be from -infinity to -1, and from -1 to 2, and from 2 to +infinity. All what we had to do exclude the VAs. As for the range we're only excluding 0, the horizontal asymptote, -infinity to 0, and 0 to +infinity. Number 2, I have this function right over here. So the first thing we want to do with this function, we're going to go ahead and factor the top and the bottom. If you were to factor the top, it's going to go x minus 4. We want the product to be -8, the sum is -2, and will be x plus 2. On the bottom, the difference of 2 squared, it's x minus 2, x plus 2. As you can see, the factor that's going to reduce right here is x plus 2, which makes the whole as if x plus 2 is the factor that you reduced, meaning x equal -2 is where we're going to have a hole in the graph. However, this function is reduced to this, x minus 4 over x minus 2. This is what we're going to focus on. We want to focus on this one to find the remaining parts to that problem. So if we want to look for a vertical asymptote, we're going to set the denominator equal to 0 and solve for x, and x is equal to +2. If we're looking for the horizontal asymptote, we look at the exponent of x. Here is 1 and here is 1. Same exponents, we divide the coefficient. That's 1 equal to 1 over 1, or simply 1. Next, we're going to look at the x-intercept. The x-intercept, as you can see, we make the numerator equal to 0, and in that case, x equal to 4. And for the y-intercept, we're going to put x equal to 0, and so if x equal to 0, that means y equal, forgot the function, x minus 4 over x minus 2, so that will be -4 over -2, or simply a 2. Alright, we have all the parts that we need. We're going to go ahead and graph. Okay, the graphing. We're going to put a vertical asymptote at +2. Which is over here. We're going to do a horizontal asymptote at 1. We do have an x-intercept at 4. We do have a y-intercept at 2. So here we go. We're going to go ahead and graph the graph. On this side of the asymptote, you have to make a decision. Would you like to do the top part from asymptote to asymptote, or the bottom? So I'm not going to check any points here. I'm going to go from this asymptote, cross the x-intercept, and end up near the asymptote. On this side of the graph, I am going to make an educated guess. Since I have to cross the y-axis in here, I'm going to start near the asymptote, cross the y-axis, and then end near the asymptote. Now the only thing left for us to do is the hole. And look at your notes, the hole, there is a hole at x equal -2. So we're going to go from -2 up to the graph and make a hole in the graph just like that. Make a little circle, and that's the hole in the graph. The last thing we want to do is find the the domain and the range. As for the domain, we want to go and count all the number on the x-axis. We're going to exclude the hole, and we're going to exclude the vertical asymptote. So now how do we go on the number line? Exclude those two numbers and count everything in between. So we go from -infinity to -2. We're going to go from -2 to +2, and then we're going to go from +2 to +infinity. That's the domain. As for the range, we're going to exclude again the whole and the horizontal asymptote. Now I'm going to take you back over here for 1 second. When we found the whole to be at x equal -2, I need you to plug back x equal -2 here to figure out the y. So the y will be -2 minus 4 over -2 minus 2, would give us -6 over -4, or simply 3 over 2. The reason I want you to find this number 3 over 2, because you need to know 3 over 2 is right over here on the y-axis. This is where the whole on the y-axis is, so we have to exclude it from the range. So when we write the range, we go from -infinity to 1, the horizontal asymptote, and then from 1 to 3 over 2, and then we go from 3 over 2 to +infinity. Done. Graphing this rational function, the first thing we want to do is factor the top and factor the bottom. What's the product of -12? The sum of 1. So that's going to be x plus 4, x minus 3. On the bottom, I want you to factor out the 4, and that will give us x minus 3. If you reduce this factor, you will know you have a whole at the x minus 3 equal to 0, which makes it x equal to 3. However, this function here, it will reduce to f of x is equal to x plus 4 over 4. Or if you want, you can reduce it a little bit here so you can identify the function as linear. This is f of x equal x over 4 plus 4 over 4, or simply it's going to be 1/4 of x plus 1. This is no longer a rational function. This is a linear function that has a hole in it. So now what I want you to do is, if you were to plug in the x equal to 3 into that function, you will get a y equal 1/4 times 3 plus 1, which gives you 7/4. So the whole is going to be in the ordered pair 3, 7/4. This is all what this graph has. It has only a whole. It doesn't have a vertical asymptote, doesn't have a horizontal asymptote. Let's go ahead and graph it. So when you graph this function right over here, you're going to go ahead and graph a line. You go to the y-intercept of 1. We're going to go up 1 and over 1, 2, 3, 4. So this is the 4. And we're going to go ahead and graph the line. What's special about this line right here is at the point 3 and 7/4, right here, there's a hole in the graph. You just make the hole, and this ordered pair is 3 and 7/4. This is how you graph this function, and we're done.